So in this example, we're going to look at problem solving using functions. In the example, you can read, during a locust plague, the area of land eaten is given by A equals 8,000 times 2 to the power of 0.5 n hectares, where n is the number of weeks after the initial observation. A, find the size of the area initially eaten. So the area is calculated by 8,000 times 2 to the power of 0.5 n. Therefore, the initial area eaten is going to be 0 when n equals 0. So we're going to substitute this n to equal 0. So area equals 8,000 times 2 to the power of 0.5 times 0. That gives me 8,000 times 2 to the power of 0. Anything to the power of 0, anything to the power of 0 equals 1. So that becomes 8,000 times 1. Therefore, the size of the initial area eaten is 8,000 hectares. If we go on to part B, it says find the size of the area eaten after 1 week and 4 weeks. So for the first one, n is equal to 1. We're going to substitute that into the function. A equals 8,000 times 2 to the power of 0.5 times 1. If you work that on your calculator, 11,313 hectares have been eaten after week 1. In the second part, all we're going to do is we're going to make n equal to 4. So we're going to substitute that into the same formula, in the same function. 8,000 times 2 to the power of 0.5 times 4. That gives us 8,000 times 4, which is 32,000. We can write a statement. Therefore, 32,000 hectares have been eaten after 4 weeks. Part C, just pause the video here. Try to run that function on your calculator and see what it looks like. So my one turned out like this. There you go. I've got a function that's running up here. Okay. And now we can use that function, that graph, to answer part D. It says, how long would it take for the area eaten to reach 50,000 hectares? So what we can do here is, well, what I've done on the graph is I've dotted a line across at 50,000. It goes across, and then I've marked it down to the x-axis, and here you can see it's 5.29 weeks. However, it's better in this case to pause video and do that on the calculator. So I'm going to do the function, which is 80,000 times 2 to the power of 0.5 times, and I'm going to do x in this case. At the same time, I'm going to do a second function, y2, which is 50,000, because I'm going to try to find out what that intersection is. So once I've done that, I'm going to go to window, so I can set my domain and my range. For x minimum, I'm going to set it as 0. And then for x maximum, I'm going to put it in at 7 weeks. You can put it in 10 weeks, it's just an estimate at this point. For my range, y minimum, I'm going to set at 0. And y max, I've just set it at 80,000. Then I press graph, and it starts rendering my two graphs. Here I can see the intersection. I'm going to use that. I'm going to do shift calc or trace in order to find that intersection. So option 5 says intersection. It gives me an option to select the first curve and the second curve, and then make a guess, an approximation. And then that you can see says at y equals 50,000, I've got x at 5.2877124. So I'll round it up to 5.29 weeks. So 50,000 hectares would take 5.29 weeks, thereabouts. Okay. All right. Thank you so much.